presented and won multiple prizes for his innovative solutions. The ones we found most impressive were models he built for the Farm Pin Crop Detection Challenge and Wazihub Soil Moisture Prediction Challenge, both of which he was ranked #1. His success is impressive, as Dr. Fadahunsi's knowledge in machine learning is largely self-taught. Without much ado, I would like to hand over to Dr. Fadahunsi to take over. Thank you.
Yes, thank you very much for that succinct introduction. Again, I'd like to welcome everyone to this webinar session where I'll be talking about growing the data science skill set. As introduced, my name is Yinka Fadahunsi. I also work with Stanbic IBTC Bank as a data scientist. And on data science platforms like Zindi and Cargo, I am known as Dr. Fad. Without further ado, I would switch now to the presentation. Like we're introduced in the opening remarks, please take down, to get the best out of this session, take note of your questions. You could post them in the comments area. And just to manage the limited time we have, we'll take questions at the end of the presentation. But be rest assured, I will devote majority or a sizable amount of time towards the question and answer section so that we could address your concerns and elaborate on areas that need further clarity. So I've given a bit of introductions about my journey, but I'll use these infographics just to elaborate a bit further. I'm sure, so on the call, we have a mix of different skill sets. We have both beginners, we have people who don't have an idea or just want to understand more about data science. We also have experts as well on the call. But I would like to start by showcasing my journey so far in data science. I started off sometimes in 2017, where I was enrolled into a 3-month boot camp. And upon completion of the intense bootcamp, where we were exposed to program languages like R, Python, handling big data using the Hadoop platform, we learned a few concepts in visualization using ClickView and so on and so forth. The 3 months bootcamp was very intense. And upon completion, I went to South Africa to sit with some experienced data scientists just to transition the theoretical knowledge I have into practical knowledge. So the entire 6-month program in 2017, I would say, was the beginning of my journey. Upon completion, I started doing lots of hands-on at work and also started participating in data science competitions in 2019. Popular competition websites like Zindi, as we've been introduced in the opening remarks. Zindi is a data science platform majorly for Africans, but we'll find out that some data scientists across the world from the UK, Russia, United States, Canada, Europe, India, China, also participate on this platform. For me, I find out that this particular phase of my data science journey was very instrumental in the sense that it helped me own the different skill set that I have and also helped me to expand my data science capabilities, right? And fast forward in 2020, in addition to the work I do with Stanbic IBTC, I also provide mentorship to a handful of students from the University of Texas of Austin on their postgraduate diploma certificate program in data science and business analytics. And you can see the last chunk here. It's graded out. It's something I'm working on to establish like a data academy where learners could come and learn everything data, and also establish some consultancy services where I collaborate with businesses to help deploy and build data science models. So a few of the things that I'm a bit proud of, awards and accomplishments. I've ranked first position in most of the competitions I've been on. and also maybe top 2, top 3, and so on. But the ones I'm most proud of are the ones here. So there was this Microsoft challenge, which charged data scientists across the world to predict mortgage approvals, whether the government of the United States would approve a mortgage or not. I came number 1 on that competition to the far left. Another interesting time series data set and challenge was hosted on Zindi, the Wazihub Soil Prediction Challenge. And as you can see, most of these competitions comes with huge benefits, both to the data scientists who participate and also to the companies who host the problems. On the one hand, data scientists get to improve their skill sets, broaden their horizon. If they win, they get to have bragging rights, and in some cases, they are rewarded with some financial returns. So this particular Wazihub Soil Prediction Challenge was a time series challenge, or popularly known as a regression challenge. And it was in the field of agriculture using Internet of Things. So today, like we all know, we are connected by data in a large sense, right? And there are some particular devices called Internet of Things that takes readings. In this particular case, there was a farm somewhere in Senegal that wanted to optimize their use of water in irrigating their farm crops. So this challenge was just to look at the most optimal approach of water usage to help farmers be more efficient in the business that they do. I came number 1 on that challenge. You can also see that someone from Russia came number 3 and Tunisia number 2. On satellite imagery as well, another popular subdomain within data science, on this particular one was to build a model that would help farmers in South Africa for this particular farm field identify the crops grown on a field or an area using satellite images. So this one was very challenging. At the time, people didn't really know much about the domain area. Lots of us had to read extensively, research papers, and then build algorithms to do that. It was quite rewarding because for me, I learned a lot, and I also came out top on that competition. Number 2 here was someone from the UK. Number 3 is someone from South Africa. So that's like a bit of the background about me. Now I will dive into the core of today's session. Let me start by walking us through the outline. First, I will talk about why exactly data science it's important today. What do we need? What can we do with data science? And to the area where most of us are interested in is focusing on those 3 main steps you need to take to become a data scientist. For those who are beginners, for those who are just gathering knowledge to being a data scientist, and for those who would like to advance their data science skills, all of this will be very useful to you. I would share with us some key resources that I've gathered over the course of my career, which I think if you also adopt will be quite useful to your data science journey. If you're about to start, just started, or already on that phase. And if you wait till the end of the presentation, I'll give you like a bonus. Some practical tips that I've gathered in terms of experience on how exactly you can win data science competitions. So this will be very practical. There are 6 of them. I could summarize it to 6 of them. And I'm sure once you begin participating in competitions and you apply this, definitely you'll be top 10, top 3, or even win the competition. Like I mentioned, to manage the session in the most effective way, we would keep questions and answers towards the end of the session. And trust me, I would try as much as possible to provide clarity to your questions. So I'll try and power through the presentation and leave ample time to address the Q&A sessions. All right, so the first part is why data science? So there was this article by Harvard Business Review, sometimes in 2012, said data scientist, being a data scientist is the sexiest job of the 21st century. This for me was a very important article because it actually drew my attention to the possibilities within data science and what I can do and achieve as a data scientist. I'd encourage everyone to go read this article. It's on Harvard Business Review. Just put this header in on the browser and you'll be sure to find the article. So why data science? In the climate that we are today, indeed, to some extent, we are all data scientists. We've at some point in our life done some prediction, and I'll give a clear example of one that most of us have done at some point in our life. Say, for example, it's about to rain. The cloud becomes a bit dark. The weather becomes a bit humid. Then it becomes windy. And in our mind, we're saying, based off of these factors, there is a high likelihood that it's going to rain. In a large sense, you've actually been a data scientist doing that. Because what you've done is just based on experience and knowledge of historical happenings. You've said when it's dark, when it's windy, if it's cold, there's a high likelihood to rain. And that is forms the bulk of the task of what data scientists do, right? Predicting future occurrence, leveraging past data. But then it becomes a bit more complex in real terms, where our normal brain can handle, where computers come into play, right? Computers have the ability to learn complex relationships within data and then help us predict the future. But whoever programs such a computer is what we call a data scientist. And today, we've seen, because of the advent of increase in data sets that are gathered today, we've seen a huge demand across the world for people with data science skill sets, right? What we've also seen is that the supply of data scientists, those coming new into the industry, isn't growing with the same pace of the demand. So what that means, for those of us who have like an economics background or took some economics course in our secondary school education or probably even in tertiary institutions, when there's a huge demand and the supply is limited, what happens? The price goes up. And this largely translates directly to what we see in the average salary earned by data scientists. So another reason why you want to be a data scientist is you earn a good salary. Obviously, I can't tell you what my salary is, but the median or average salary, as reported by sites like Glassdoor, PayScale for data scientists, stands at about $113,000 a year. Depending on the industry you're in, this could go as high as $150,000 or as low as $80,000. Facebook, for one, I know their graduate data scientists earn in the region of about $150,000 a year as a fresh grad from university. So you can see how rewarding this career is. And for me, the most interesting part about data scientists is that it's actually universal, because data occurs in every area. Data scientists, who are those people who have the ability to make sense of data, are needed everywhere. Like I kind of alluded to in my opening remarks, you saw that you could actually apply data scientist skill sets in the IoT industry, in agri, in logistics, in the finance industry, in the medical industry, and so on and so forth. So it's universal. The skill set you have would always be in demand and would allow you to transition into multiple areas. Again, I work in the financial industries, but I've worked with several data sets across industries, the agriculture industry, in the medical industry, in logistics, and so on and so forth. So, I mean, data science is here to stay. And if we adapt the skill sets to become a data scientist, we can't go wrong. We'll become instantly relevant in our respective work if we're already in employment. And if you're looking for a job, it will stand you out if you put this on your resume that yes, indeed, you have data science skill sets. So having had that introduction, the next thing is for those who are beginners, for those who want to advance their skill sets, what do I need to do to become a rounded data scientist? And I've broadly summarized this into three areas. The first of which is to obtain basic training, right? Training in maths, statistics, in programming, understanding of some domain area, and then ultimately visualization. Once this basic training and skill sets have been gathered, now for you to, another step towards being a data scientist, you need to complete a data science project, right? So what that means is you pick a particular problem, try to solve that problem using the data science skills and experience you must have gathered in step one, which is the basic training. And then lastly, you must continuously evolve your skill sets. And one way I find this practical and useful is you need to keep solving real world problems, all right? Because technology, as you see, it's a very fast moving kind of business, right? The knowledge you have today might become obsolete tomorrow. So for us in the technology space where data scientist falls under, you need to constantly have that mindset of regularly sharpening your skills and updating them with the most up-to-date skill sets, technologies, and algorithms. So one way you can actually do this is to continuously solve real-world problems. I'll elaborate a bit further on step one. So there are various ways you can the basic training. For starters, you could enroll, like I did, into a boot camp program, and then progress with that. The internet, as you see, has a plethora of online resources. If you Google today, as I'm facilitating this session, bootcamp in data science, I can tell you for certain that you would see minimum of 6 that will pop up to you. If you're not the bootcamp, you don't have the luxury to dedicate some time into focusing just on data science via a bootcamp, which is usually accelerated. You can actually start off with enrolling in online classes. Again, there are a plethora of resources online. There's DataCamp, there is Coursera, and so on and so forth. You could buy books if you are the kind of person who likes to be self-taught. There are several books out there that teaches you the skill set required in data science, but I would recommend once you go this route of self-teaching yourself, you need to try to have a mentor, someone who is experienced and currently does data science. Finally, you would have to pick a programming language you want to use. There are 2 popular programming languages for data science. There are more, but 2 of them stand out, and they are R and Python. You might want to ask, what are the differences between R and Python? They're similar. The difference is one is R has more statistical packages to help you do your stats and maths, while Python is more friendly when you want to take your solution to production. By production means a working solution where an end user, it could be a customer or could be a department, is then using your product. Python has those libraries that helps you take your product or your work to the next level for end user consumption. But with R, if you have this stats and maths background, R is the go-to language. It has lovely libraries for statistics. It has lovely libraries for visualization and so on and so forth. For me, because I was introduced to data science through R, I use R, but nothing stops you from going to Python. Python has a lot more followership. If you Google now, you'll see Python has more users, but we also have R users. The number one person on Kaggle, so Kaggle is another data science competition. I know uses both languages like I do, but uses more of R. You know, they are also very good data scientists who use Python. But let me try to take you through some practical demonstration, right? Of how to get started. So I mentioned some resources where you could take courses, and one of the resources I would like to recommend is DataCamp. They are not paying me to promote this. I use it, as you can see. These are the number of points I've gathered by taking different courses, about 66,000, several points. And for me, I like it because it's a one-stop shop for everything data. Unlike the likes of Coursera, where you find data-related courses, you find software development-related courses, you find some business-related courses, datacamp.com focuses strictly on everything data, right? And let me just walk you through how you can go through it. On a normal day, it's about $300 for a year subscription. More than often, from time to time, they offer discounts. It could go as low as $100. So if you're looking for value for money, you could just register and just hope for when they would have this pay slash, and you can then subscribe. So for example, if you've registered, you have an account and probably you've made payments for a subscription, what you can do is to go to learning, and under learning, you scroll down. I wonder why. Okay. You scroll down to career tracks, right? For example, wait for that to load. And again, what you would see are different career tracks. You could go for a career track which will take you 48 hours to be a full R programmer. You could go for data science with R, 76 hours, 19 courses. If you want to be just a data analyst, it's here. Everything is embedded. For data scientists, you could either choose the Python track or the R track, like I earlier mentioned. So assuming you go for the R track, if you click this, everything is structured. You don't need to have any programming knowledge or any background, right? It takes you from ground zero to ground expert. So it starts off, the first course is arranged, right? 4 hours course, introduction into R. You move on to intermediate, and it gets advanced and so on and so forth to the very last course there, which is, I think, a capstone project, if I'm not mistaken. It should be a project. Scroll down. Yeah, okay, no projects, but I mean, that's that. So that's how to use DataCamp. If, for example, I'll recommend this now for those who are in employment, they have probably the financial means. You could go to this program, where I also told you I take classes. It's the program from Texas of Austin, right? It's a 6-month program. At the end of the program, you get a certificate. It's something that's industry recognized. Like you can see here, this program is ranked number 2 worldwide. And it's unique in the sense that you have learning sessions with mentors like myself, where if you've seen the video during the course of the week, you then engage a mentor during the weekend to clear your doubts. So this is another good resource I recommend to those who have the financial means and who probably don't have like the luxury of attending the boot camp, or they don't like this method of going online to do like a course with their own pace. This will actually pace you up, and I mean, at the end of the day, you get a certificate. Also on DataCamp, you also get a certificate. Okay. So let's go back to the presentation. I also mentioned once you're done, you need to do a project, right? And for you to do a project, all you need is a data set. And data sets are readily available on Kaggle, which is data science competition, and on Zindi. All right, there's also data.gov hosted by the US government. Lots of data sets. But I highly recommend you to visit either Kaggle or Zindi. Let me just show you how you can easily go on Zindi to pick a project. So once you come on Zindi, you register. There's a tab here called competitions, right? And within competitions, you would see paid competitions and knowledge competitions. For a beginner, you could actually go with a knowledge competition, right? And then try to solve this problem by downloading data sets, writing a report, and then that would help you a long way to becoming a good data scientist, right? So once you do that, the third step is continuously participating in these competitions. You can then gravitate to paid competition, where if you win, you get financial rewards or you get bragging rights. You can't lose in this case because once you participate, you're obviously improving your skill set because now you've tried to solve a problem that you didn't really necessarily know how to solve in the past. So obviously you've advanced your skill set. So it's as easy as that. I will encourage everyone to pick one of these suggestions, go to DataCamp, go to Coursera, go to EDX, and subscribe to an online bootcamp or an online class, and then complete the basic training. Once you're done, move to project mode. That will give you the confidence that yes, indeed, you can tackle any data science problem that you encounter. So broadly speaking, to become a data scientist, you have to develop skill sets in 4 broad areas. I mentioned it earlier. The first of the area is your maths and stats. No single area is more important than the other. They all work hand in hand. And what I find out with my experience is that oftentimes to be a data scientist, you are more inclined to be very good at 1 or 2 areas and just have basic knowledge of the other areas. That's fine. But for you to be an excellent data scientist, I would advise you to focus on all of these areas and try to own your skill sets. So starting with maths and stats. Within this subdomain, you would focus on sub-skill sets like algebra, probabilities. Like I mentioned, data science, we try to kind of predict, the probability of occurrence, probability of it being this class. Imagine you have like an image classification problem where you want to build an algorithm that will help you detect whether this is a cat or this is a dog. So the concept in probabilities will help you evaluate how your model is performing. And you need some good idea in descriptive statistics, like mean, median, mode, standard deviation, variance, just basic concepts, and inferential statistics. So oftentimes in data science, you are charged with the task of building a model, right, using a subset of a population. So a population, for example, could be total number of people or the population of people in Nigeria, all right? But imagine if you want to build a model to say, what is of Nigeria, or what is the average age of Nigerians? So actually get that exact number, what you need to do is to interview every single resident in Nigeria. And last time I would check the statistics for Nigeria, the population is in excess of about 220 million plus, right? So imagine how resource intensive that would be. You would spend lots of man hours interviewing people. You would spend lots of money, all right, conducting this interview. So oftentimes in data science and statistics, we work with the subset called a sample, right? Which is why statistics is important. And once we're working with a sample, we want to infer, that's inferential statistics, how confident we are that that sample is indeed a true representation of the population, which is about 220 million plus in this case. So, which is why inferential statistics is very important, because oftentimes we work with sample, and when we work with sample, we need to communicate our confidence levels to whoever is consuming that report to say, I work with this sample of 1,000 people, and based on that, I think they have, I have a confidence to say that based on these 1,000 people that have an average age of say 35 years, I have a confidence of plus or minus 3 years, meaning if you indeed go to the full population, I am confident that the average age of Nigerians would be between 32 years and 38 years, which is 35 plus or minus 3 years, that kind of stuff. So inferential statistics is important because it's very expensive, and both in terms of finances and man hours, to do computation on the population data. Rather, we work with sample data and then showcase the level of confidence. The next domain area that makes you a rounded data scientist is programming knowledge. All of the maths, all of the domain knowledge will be useless if you can't interpret this into programs, right? And like I mentioned, the two popular programs are R and Python, right? So you need to know a bit of both of them or just one of them, the preferences there. Like I mentioned, there are other languages you need to know as well. People use Java, but not as popular for data science. Scala is a language more in line with advanced data science analytics. When we begin to talk about big data, handling large amounts of data sets, then you most likely want to use Scala or a variant of that, PySpark. SQL is another very important language because oftentimes the first stage of any data science work is to gather data from a database or from a store. The database is just simply a repository of data, okay? And for you to extract from that repository of data, oftentimes you need SQL, a scripting language called SQL, to collect data. Once you collect it, it goes into your R script or Python script to build your models. And once you're done, we move to the third domain, which is communication and visualization. All of the work we do as data scientists will be useless if we can't communicate our results in the most basic format to someone who has no data science experience, right? To an executive if we're in the workplace, or to an audience of non-data scientists, right? You need good quality communication skills. Imagine you've built this complex statistical model, you've done the R programming excellent, you spend hours and hours of man hours, and your work won't sit on R or on the stats side of things. You need to showcase it to an end user, right? Be it via consumption or via analysis for decision making. You need to showcase it. This is why communication skills are very important. So what are the tools we use for communication and visualization? You know, in summary, trying to condense all of the work we've done earlier to an end user in a very infographic way, simple way, via a dashboard and things like that. Tools in that area are tools like ClickView. It's a visualization tool for building dashboards and building infographics to communicate your findings. There's also Power BI, similar to Click. And there's also Tableau, similar to Power BI and Click. And do not underestimate the power of the usage of PowerPoint, Microsoft PowerPoint, or any PowerPoint tool to showcase your results, right? That skill set is also very important. And lastly, you need some soft skills. To be a data scientist, if you are good with the technical side of things and you can communicate your findings to the most granular level in the most effective manner, then you wouldn't have that much success in data science. So improve your communication skills, take some courses on public speaking, how to write a report, and so on and so forth. And again, the last domain, which is often overlooked by people, is the domain knowledge area. For you to be able to solve a problem, you need to understand that industry. If you don't understand that industry, it will be garbage in, garbage out, right? Because you'll be misinterpreting the industry. And I'll give an example. The satellite image competition I won, prior to that competition, I had zero clue of satellite imagery and how to analyze it for prediction in the agri industry. What did I do? I went as far as going into research papers to read everything I could learn about satellite imagery analysis for agriculture. It was then I understood some things that allowed me to then use my programming skills to create some new features or columns that would help me interpret or predict an outcome, all right? So this is where creativity comes in, the ability to learn via reading research papers, speaking to people who are experts in that domain. So all of these 4 areas are very important. I wouldn't say one of them is more important than the other. To be a data scientist, you should have a bit of knowledge in all of these areas. Maths and stats to give you an edge. R programming, very key, or Python programming, because you need to interpret and build your models. Domain knowledge, key, because it helps you building good models that are interpretable to the audience that they're communicating to. And finally, and very important also, is your communication and visualization skill, right? Which helps you showcase the technical work that you've done to end users. Once you've finished this area of gathering your skill sets, like I mentioned, you need to continuously sharpen your skill and develop yourself. First thing is to pick a product, a project, and create a data science report. Once you've done with your bootcamp, online class, a certificate program from a university, you need to pick a project. This will give you confidence to say, yes, I can actually solve any data science problem, right? And once you're done with that, as a going concern, I would recommend that you at least participate in 3 data science competitions in a year or more, but at least 3. Why? Like I said, you can become obsolete quickly because of the fast-moving technology landscape that we're in. Things are released every day, you know, new ideas are released every day to solve a problem, right? So you only get close to new solutions if you stick close to new problems and interact with data scientists on such platforms like Kaggle and Zindi, where they will showcase their ideas, right? So that's very critical. And lastly is, once you complete a project, be confident in yourself, share your results. And to share your results, let me show you quickly. You can do that using GitHub. You may not know how to do that now, but so GitHub is like a community of developers who post their solutions. Like an example here is this particular user, Jonathan Bratt, who has published a solution on RBET. So RBET is an algorithm used to classify text into different classes. Imagine now that you've done an online survey. People are putting verbatim feedback, right? But then you need to group this verbatim feedback into categories, like to say, okay, people who like maths, people who like English, and so on and so forth. But they're giving you verbatim feedback like, when I was in secondary school, I used to enjoy my maths class, right? But then you want to classify this into a category to say, okay, if you said that, that means you're talking about mathematics, and so on and so forth. RBET or BET is actually like an algorithm that you can build in both R and in Python that would help you classify text into this class cases. So this particular user has published his code here You can read about the description of his projects in the README files here. You can actually read about the actual code in the RMD files and so on and so forth. So if you go here on GitHub, you'll see different repository of code that you can actually go copy and then utilize and amend. All right. So once you're also done with your own, I would encourage you to showcase your findings on GitHub, go on LinkedIn, publish your presentation, let people comment. That is the way you can get better. Okay. So I've mentioned a few key resources. I'll mention more. But if you look at the image to your bottom left, you say, look at the frustration in the developer there. So when Stack Overflow goes down, boom, boom, chow, problems will emanate because most developers across the world are heavily reliant on this particular website, Stack Overflow, right? As a developer, more than often, I can tell you, you would go to this website to check for a solution of how to do a particular task, right? So it's a useful resource. I use it from time to time. If I'm hanging somewhere, finding difficulties programming something, I just go on Stack Overflow, search, and it's quite easy. And I'll show us how to do that. Again, Zindi, go to their competitions, go to the discussion. Let me show you the discussion area. In the discussion area, people talk about ideas. You can learn from those ideas. People share their code, you know. So this is the discussion, for example. Click on any one of them, you'll see useful insights. Similar on Kaggle, but the additional benefit of Kaggle is that you can even actually have actual codes on the platform where you can just copy, amend slightly, and use for your own particular problem. You know, so Kaggle is useful for that. I've mentioned Data Camp as an online resource where you can go to the data science skill track, subscribe, dedicate some time, complete it, and become a runner data scientist. There are other sites like EDX, Coursera, talked about the PGD program in Texas of Austin, and so on and so forth. Stack Overflow, it's one key resource people underutilize, and I would show you exactly how to use it. So if you're stuck on a problem, oftentimes you will be, right? Because the universe of data science is very broad. You're not expected to have everything in your brain or learn everything in 1 month, 2 months, or 1 year. Sometimes you want to learn something new or try to solve a problem. You just go to Stack Overflow. This is an example of Stack Overflow, right? If you Google how to, so for example, how to do row-wise statistics with data frame containing several columns with NAs or empty values in R. You ask your question, and I can tell you in less than 20 minutes, the solution will be provided. But you need to be cautious here. The first bit of work you need to do is to search the whole website for a similar question that has been asked in the past, and then just look at the answer that has been provided then. But if you've done your homework and combed the website, you haven't found a similar question, you can actually ask your question in very simple steps. If you're logged into Stack Overflow, you go here to your top right, you come to, where's ask a question? You come to ask a question, and then you just type. You just type. And within a few minutes, someone will answer your question. So Stack Overflow is very important. I would encourage everyone to go on this website. And this is, the list I have here is not exhaustive. There are more. I would encourage you to explore, discover new ones, add it to your repository of knowledge, and you'll be one step closer to becoming a rounded and quality data scientist. Now to the end, bonus tips on how to win competitions in data science. So far, we've talked about the 3 main steps you need to take to become a data scientist. First, you need to acquire the basic knowledge. And I've told you, data scientist, the knowledge areas are broadly split in 4 areas. It's the maths and stats, understand a bit of that. Don't be overwhelmed by the maths, just understand the basics. R or Python programming, understand how to use them. Visualization, know how to present your outcomes in a report, in PowerPoint, or on a dashboard, in ClickView, Power BI, or Tableau, and try to build and expand on your domain knowledge. So domain knowledge simply means the business area, understanding of that. Once you're done, pick up a challenge and then continuously task yourself in learning new things, right? However, to win competitions, it's a whole different ball game, right? An extra 0.0001 give you that edge to win that $11,000 or $5,000. So you need to squeeze in everything you can get. So the first thing I would recommend is always start by understanding the problem and exploring the data, right? Don't be overwhelmed if you don't know what this is all about. Those who have experienced data science will probably understand, but I'm just giving you the end states for beginners. Don't be overwhelmed. Once you get there, you understand that the first thing you need to do is to understand your data, explore it using graphs, understand everything, first of all. Once you're done with that, then you need to select the right algorithms. So all of these algorithms have been pre-populated by people in the open source environment. So open source just means several developers come together to create a package to do a particular task. So XGBoost, for one, has been bundled up for an end user, a data scientist, to easily just take and use to make predictions, right? Without understanding how to code the maths and stats behind it. You don't need to understand that. All you need to understand is just the concept and how to use them. So you need to understand how to use the right algorithm. And from what I have seen, from participating in competition for about a year plus now, is that for structured data, right? So data sets in tabular form, right? Let me create a table. Say you have age, you have occupation, you have salary. You're trying to predict whether a loan will be granted or not. Okay? Several age, 23, 45, 27, and so on and so forth. Occupation, banking, nurse, and so on, teaching. All right? The salary, say 20 million, say 25 million, say 7 million, right? And now you want to build a model whether this person should be given a loan or not. You see? So this now, because it is structured, oftentimes structured data like this that you can put in tabular form, I would advise that you use XGBoost or a variant of a gradient boosting algorithm. So there's XGBoost, there's CatBoost, there's LightGBM. But if you have competitions that are unstructured, right? Unstructured data means data sets like images, like voice, like free text, right? The algorithms that perform well, and most of us might have heard of it, or some of us might have heard of it, are what we call the deep learning algorithms. So it uses like neural networks and complex combinations of interpretations and relationships to come up with answers, right? They call it deep learning algorithms. For images, the particular algorithm that is proven to be very good for images is convolutional neural networks, or CNN. For text, I've showed you one in passing. It's a library or a framework called BERT, B-E-R-T. It's very good for NLP challenges. And what else? For voice, oftentimes you can convert voice to images, right? So all of those frequencies that we usually see, you can convert it to images and then convert it to like a CNN kind of tax. So well, basically, for structured data, use a gradient boosting algorithm like XGBoost, LightGBM, CatBoost. For unstructured data, use a deep learning algorithm like CNN, BERT, and so on and so forth. Third is always research the domain area. Your ability to research and understand the particular domain would help you in creating useful features that would build better models, right? So 4 and 3 are kind of related. Your understanding of the domain knowledge will help you do feature engineering. So feature engineering is just basically manipulating your data, creating new data, and so on and so forth, right? Second to the last thing you need to do is to always tune your model. So for those who have the idea of decision trees, for example, and for those who are beginning their journey, you will learn decision trees at some point. These algorithms have parameters. It could be the tree size or the tree depth, or it could be number of iterations. Oftentimes, you will have to tune those parameters to get the best model, right? And finally, and the icing on the cake, is what we call ensemble methods, like boosting, bagging, and stacking. So ensemble method just simply means, in its layman term, adding two or more models to get one powerful model. And I'll try to bring it down to context, something relatable. So imagine you're going to Who Wants to Be a Millionaire, right? And they've told you beforehand that they will take you on questions on history, on science, and on something else, okay? And they're giving you the opportunity to bring 1 or 2 friends, right? So imagine you're asked a question that you had no clue about, say an history-related question, and you have 2 historians as friends and 1 scientist. Yes, you can ask all 3 of them for a particular answer, right? And you can also weigh your answer. Say you ask the historian, what's the answer to when country X had independence? Say it was 1980. That's the actual answer. First person historian, because he's good at history, tells you 1979, right? He wasn't that sure, but it was close. Second person tells you 1980. Third person tells you 1980. Then you ask a doctor. Doctor has no clue of history. He tells you 2000, right? You can actually get a better output by aggregating all of the answers that you've gotten from each of these experts. So imagine now that you take the mode as your final answer, you will get the answer. So that's basically what we do in Ensemble, combine feedback from different algorithms to get one powerful algorithm. So 6 tips, if you implement them, you could rest assured you become top 10. And you take it to the next level, implement them to the tits, to the dots. I'm most certain you win your first competition. Then earn the right to brag or earn money while you do it. That marks the end. We'll take questions. My name, again, is Dr Fadahunsi. You can find me on LinkedIn. That's my profile to the bottom left. Or you could type Yinka Fadahunsi, look for me and add me. So yeah, we'll pretty much take questions. But before I go and take questions, I'd like to do more of this, but I'd like to get your feedback if you found it very useful. Maybe subsequent sessions, we could start going into some of these domain areas and then make it more hands-on, right? Where we learn actual skill sets in data science. So on my page, I posted something about this webinar. Just drop a comment there on LinkedIn if you want us to continue with this series, expanding your skill sets in data science by actually going granular, showing you how to use R or Python or how to actually build a model, right? So that's that. I'd like to thank everyone for joining this webinar. For me, I think it was successful. I like the fact that it was engaging. I saw your messages. And just as a closing remark, would like to give thanks to Professional Voices, a platform that brings to you quality content from industry leaders, experts like myself, in different career fields, and also encourages peer-to-peer knowledge transfer amongst professionals. This webinar was powered by OnlineRadio, the leading lifestyle and first multi-channel internet radio with audiences across 99 countries across the world. Please make sure to download the app. It's available on Google Play Store if you're an Android user. Also available on Apple Play Store, App Store if you use iPhone. They have amazing content segmented into different channels. Channels including music 24/7, talk shows, professional voices, and audio stories to keep you engaged all day long. What you need to do is just simply visit their website. It's on www.onlineradio, meaning lowercase, .com.ng. Again, www.onlineradio.com.ng. So visit the website to know more. Lastly, we would also like to appreciate Include co-facilitating this webinar. Include, they are an inclusive development organization promoting economic opportunities to persons and communities with disabilities. Once again, thank you very much for joining the session.
Okay. And, all right, so thank you, everyone. And we'll be sending you emails. We'll be sending you emails with the links once again to listen to this video again. And we'll also be sending you the resources that the resources that Yinka mentioned with regards to the data science. So thank you all.
Hello, everyone. Just as on a parting note, like we said, Dr. Fad, thank you very much for this wonderful webinar. So much learning points. I mean, I'm already beginning to feel like I'm a data scientist myself. Anyway, just to tell us, please watch out for the newsletter, and you can also send in your questions. Let us know maybe other areas that you might be interested in learning. And regarding the mentorship and internship, we will be taking it up, so expect an email from us. And also just to say that we also have more and more of this webinars coming up. In fact, the next one we have is on 9th of May, and that will be 12 p.m. on the 9th of May, and we'll be looking at business analysis and leadership, how you can get started. That will be hosted by Folarin Adidamola. He's an expert in that. He's also an agile fellow. So lots of learning on that space on business analysis and leadership. And also just to say before you go, we also have a very, very interesting show today. It's being hosted on one of our channels, like Dr. Fad said. OnlineRadio is the first multi-channel. So you can go on the app. I mean, make sure you download the app, go on the app, download it, and there are lots of channels for you to tune into. And then lastly, we just want to say thank you so much, our partners, OnlineRadio, Professional Voices, and Include. And just to tell everyone, please tune in. We'll have more of this, and we hope you enjoyed it. And for us, what we really want to see a learning that is very experiential, and also learning that is interactive. Because if you will notice, one of the differences is that in our webinars, you can ask questions and you can get real-time answers. So, I mean, stay tuned, and we will be sharing more wonderful content with you guys. Thank you so much.